For decades, supersonic flight has been synonymous with the loud and disruptive sonic boom, a thunderous roar that occurs when an object breaks the sound barrier. This phenomenon has shaped our understanding of supersonic travel, making it a marvel of speed, but a challenge for widespread adoption. However, the X-59 quiet supersonic technology, a groundbreaking project by NASA in collaboration with Lockheed Martin, is poised to rewrite that narrative. This experimental aircraft represents a leap forward in aviation, designed to achieve supersonic speeds without producing the traditional, disruptive sonic boom. Instead, it replaces the boom with a soft thump, a revolutionary feat made possible through cutting-edge technology and an aerodynamic design that redefines the limits of flight. The X-59 opens the door to a future where quieter, faster travel could make commercial supersonic flight not only viable but transformative. Here's how this revolutionary aircraft could change aviation as we know it. Supersonic aircraft, those capable of flying faster than the speed of sound, have long been a symbol of technological advancement, pushing the boundaries of innovation across military, research, and commercial sectors. The Soviet-built Tupolev Tu-144 was the world's first supersonic airliner, making its maiden flight in 1968. Despite this historic milestone, its commercial career was short-lived due to economic and operational challenges. The Concorde, introduced in 1976, represented the golden era of supersonic travel, cutting transatlantic flight times in half. It revolutionized air travel for a privileged few. Yet, the Concorde faced significant hurdles: high operating costs, environmental concerns, and the infamous sonic boom, which restricted its operations to overwater routes. These limitations, coupled with the tragic crash of 2000, led to the Concorde's retirement in 2003, leaving the dream of commercial supersonic flight grounded. The quest for supersonic flight began with military aircraft, driven by the need for speed and agility. In 1947, Chuck Yeager's historic flight in the Bell X-1 shattered the sound barrier, setting the stage for a new era in aviation. Throughout the 1950s, experimental aircraft continued to push boundaries, and in 1953, Jacqueline Cochran became the first woman to break the sound barrier. The 1960s brought the rise of supersonic airliners, but the challenges of economic viability and public acceptance loomed large. The sonic boom, an unavoidable byproduct of supersonic travel, proved a significant obstacle. As aircraft like the Concorde demonstrated, the boom's disruptive nature hindered the potential for overland routes, limiting supersonic travel's reach. Supersonic flight presents unique technical hurdles. At high speeds, aerodynamic drag becomes a significant issue, necessitating innovative wing designs. Aircraft like the Concorde used delta wings to optimize performance, while other designs incorporated variable sweep wings to adapt to different flight conditions. Extreme heat generated by air friction at supersonic speeds demands advanced materials. Titanium and heat-resistant alloys are essential to ensure structural integrity, while propulsion systems like turbojets and afterburners provide the necessary thrust. For example, the State Route 71 Blackbird, powered by Pratt and Whitney J58 engines, achieved speeds exceeding Mach 3 thanks to its advanced afterburner technology. Yet, the sonic boom remained an enduring challenge. Shockwaves generated by an aircraft breaking the sound barrier produce a deafening noise that can startle communities and even cause structural damage. This disruption led to a ban on routine supersonic flights over land, limiting their applications primarily to military and transoceanic travel. The X-59 quiet supersonic technology aims to overcome these barriers by reshaping the future of supersonic flight. Its sleek, elongated design minimizes shockwave generation, transforming the disruptive sonic boom into a soft, barely perceptible thump. This innovation could pave the way for overland supersonic travel, revolutionizing the speed and convenience of air travel. NASA and Lockheed Martin's collaboration on the X-59 represents a fusion of decades of research and cutting-edge technology. By reimagining how an aircraft interacts with the air around it, the X-59 could eliminate one of the most significant obstacles to commercial supersonic flight. Imagine crossing continents in mere hours without disturbing the communities below, a vision that may soon become reality. As the X-59 prepares to take flight, it symbolizes more than just a technological milestone. It heralds a new era of aviation. The principles behind its design could influence the development of next-generation aircraft, including hypersonic models capable of exceeding Mach 5. These advancements push the boundaries of aerospace engineering, opening the door to possibilities once confined to science fiction. Supersonic flight's legacy, from the Concorde to the X-59, continues to inspire innovation, shaping the future of travel and exploration. As we move closer to realizing the dream of quiet, efficient supersonic travel, the once disruptive sonic boom may fade into history, replaced by the hum of progress. The X-59 Quest is more than just an aircraft. It's a bold leap toward a future where supersonic flight becomes as routine and quiet as today's commercial aviation. Its innovative design marks a turning point in addressing the decades-long challenge of the sonic boom, a major hurdle that has kept supersonic air travel largely confined to transoceanic routes. Supersonic travel once seemed poised to revolutionize aviation with the promise of dramatically shorter flight times. However, the reality of sonic booms, a loud and disruptive phenomenon caused by shock waves from an aircraft traveling faster than the speed of sound, curbed its potential. Cities banned routine supersonic flights over land due to the disruptive noise, relegating aircraft like the Concorde to limited routes and eventual retirement. The X-59 aims to overcome this barrier by employing cutting-edge aerodynamic designs that reshape shock waves into a softer thud rather than the sharp and explosive boom that typically accompanies supersonic speeds. At the core of this innovation is a specially contoured nose and fuselage, which redistribute the pressure waves to minimize their ground impact. If successful, this technology could revolutionize air travel by enabling quiet supersonic flights over populated areas. The development of the X-59 is the culmination of decades of research, experimentation, and technological breakthroughs. The aircraft leverages insights from earlier projects, such as NASA's Shaped Sonic Boom Demonstration and the Quiet Spike program. These initiatives tested modifications like elongated noses and telescoping booms to reduce the intensity of sonic booms. Data gathered from these experiments laid the groundwork for the X-59's design. Constructed under NASA's Low Boom Flight Demonstrator Project, the X-59 represents a $247.5 million investment in the future of aviation. Lockheed Martin, NASA's partner in this endeavor, has meticulously engineered the aircraft to meet stringent safety and performance standards. Its sleek, futuristic design is not only visually striking, but also purpose-built to tackle the acoustic challenges of supersonic flight. Testing will play a pivotal role in determining the X-59's success. NASA plans to fly the aircraft over select communities, collecting data on how people perceive its reduced sonic signature. These findings will be crucial in shaping future regulations, potentially lifting the long-standing restrictions on overland supersonic travel. Beyond the promise of quieter flights, the X-59 is a step toward making supersonic travel more sustainable and economically viable. By addressing noise concerns, the aircraft could pave the way for a new generation of supersonic airliners, enabling faster global connections while maintaining harmony with environmental and community standards. As the X-59 inches closer to its first flights, its success could redefine the possibilities of air travel. The vision of zipping across continents at supersonic speeds without disturbing the communities below is no longer a distant dream, but a tangible goal within reach. If the X-59 delivers on its promise, it won't just transform aviation. It will usher in a new era where speed, innovation, and quiet coexist seamlessly. The advancements of the X-59 aren't just shaping the future of one aircraft. They're rewriting the rules of aviation. As Lockheed Martin and NASA prepare for the X-59's first real-world flight tests, the aircraft stands as a testament to decades of innovation and collaboration. These tests will mark a significant milestone, not only for the X-59, but for the broader goal of reviving supersonic air travel in a sustainable, community-friendly way. One of the key objectives of this program is to influence regulatory changes that prioritize sound levels over speed, breaking free from the constraints that have stifled supersonic travel for decades. If the X-59 successfully demonstrates its ability to reduce sonic boom intensity to a tolerable 75 decibels, about as loud as a car door closing, it could revolutionize the future of air travel. Supersonic speeds could coexist with quiet skies, enabling airlines to operate over land without disturbing the populations below. The design of the X-59 embodies lessons from previous experiments, such as NASA's 2003 F-5E test flights, which provided critical insights into sonic boom reduction. At 99.7 feet in length and 29.5 feet in wingspan, the aircraft's sleek, needle-nose profile optimizes aerodynamics to reshape and disperse shock waves. Its top-mounted engine minimizes disruptive wave convergence, ensuring the sonic boom is transformed into a subtle, almost imperceptible thud. The X-59's innovations extend beyond its exterior. Its cockpit replaces traditional forward-facing windows with an advanced external vision system. This cutting-edge technology combines high-resolution cameras with a 4K display, providing pilots with real-time visual feeds for navigation. By eliminating the need for a traditional windshield, the aircraft achieves a more streamlined design, further enhancing its sonic boom mitigation capabilities. Incorporating repurposed components from proven aircraft models, such as the F-16's landing gear, the T-38's canopy and ejection seat, and elements from the U-2 spy plane, the X-59 is an ingenious blend of existing technology and bespoke innovation. These components not only enhance reliability, but also optimize the aircraft's overall cost and development time. The journey toward commercializing quiet supersonic travel involves more than just engineering marvels. NASA plans to test the X-59 over select cities, gathering feedback from residents on the muted sonic boom. This community-driven approach ensures that the technology aligns with public expectations and regulatory standards. If successful, the findings could pave the way for regulatory changes worldwide, enabling supersonic flights over land for the first time in decades. The X-59's impact extends beyond NASA. Startups like Spike Aerospace and Exosonic are drawing inspiration from its advancements, pushing the boundaries of what supersonic aircraft can achieve. Spike Aerospace, for example, is developing methods to redirect sonic waves upward, while Exosonic is working on a 70-seat aircraft designed to minimize boom intensity further. As these innovations gain momentum, the aviation industry is on the brink of a transformative era. The X-59 represents a bold step toward not only faster, but also quieter air travel, ensuring that the skies remain peaceful even as aircraft break the sound barrier. Its success could reignite the dream of supersonic travel, offering passengers the ability to cross continents and oceans in mere hours, all without the disruptive noise that once held this dream back. This is more than an aircraft. It's a symbol of progress, proving that with ingenuity and determination, the seemingly impossible can be achieved. The X-59's first flight will not only be a testament to the decades of research and development behind it, but also a glimpse into the exciting future of aviation that awaits us all. The X-59 represents a transformative leap in aviation, paving the way for quieter, faster, and more sustainable supersonic travel. However, challenges remain, including environmental concerns. Supersonic jets can consume up to 3 times more fuel than subsonic airliners, raising questions about their carbon footprint. To address this, NASA and industry leaders are exploring sustainable fuels like hydrogen and electric propulsion. Boom Supersonic, for example, is developing the Overture, an 80-seat jet designed to run entirely on sustainable aviation fuels. While optimism abounds, securing investment and proving commercial viability remain critical hurdles. The X-59 may unlock a new era of aviation, free from the loud, disruptive sonic booms of the past. Lockheed Martin's Skunk Works, in partnership with NASA, recently completed the X-59's first engine run tests, marking a transition to fully autonomous operation. This milestone prepares the aircraft for taxi trials and its highly anticipated maiden flight in late 2024. Engineers evaluated critical systems, including the engine inlet, nozzle, and control algorithms. The X-59 now operates independently, showcasing significant progress toward operational readiness. Pat Labau, X-59 program manager, expressed excitement at this achievement, highlighting the team's focus on ensuring a safe and successful first flight. The tests validated the functionality of its systems, including the F414G100 engine, which generates 22,000 pounds of thrust. As testing progresses, the engine will undergo simulations of flight conditions, ensuring the aircraft's readiness for taxi trials and beyond. The X-59 serves as a technological pioneer, proving that supersonic flight is possible without disruptive sonic booms. While the aircraft itself won't enter production, its advancements lay the groundwork for future supersonic airliners. NASA plans to share insights from the program to inspire the industry to overcome challenges related to noise and sustainability. This groundbreaking aircraft symbolizes a reimagining of air travel. Combining innovative design with sustainability, it offers a quieter, faster alternative to traditional aviation. The X-59 success could lead to a future where crossing continents in hours becomes standard, ushering in a new era of efficient, environmentally conscious air travel.